7.4, the Pythagorean identities. So these ones are very commonly used, just so that we also know that they can be manipulated too. I could also make this into sine squared theta is equal to 1 minus cosine squared theta. I can isolate that sine. I could also isolate the cosine and say cosine squared theta is equal to 1 minus sine squared theta. We can do the same thing with the tangents and the cotangents. So I can say that tangent squared theta is the same as secant squared theta subtract 1. I can also say that cotangent theta squared theta is equal to cosecant squared theta minus 1. So these are our new identities. I think they're my favorite identities. If you could have a favorite identity, mine would be the Pythagorean identities. Okay, so let's do some proving here. So I'm going to leave the right side alone, and I'm going to change the left side. So I'm going to start by making cotangent theta into cos theta over sine theta. So that's still from my reciprocal identities from last lesson. So we have cos theta over sine theta. And then I'm going to change my tangent theta to be sine theta over cos theta. And now what I'm going to do is I'm going to multiply to make my denominators the same. So I'm going to times this side by sine theta and this side by cos theta. So what that leaves me with is I have a cos squared theta over sine theta cos theta plus sine squared theta over cos theta, or sine theta. Let's put sine first. Cos theta. Now I could write these as one fraction, so I have cos squared theta plus sine squared theta over sine theta cos theta. From this, I know that sine squared theta and cos squared theta makes a 1, so I have 1 over sine theta cos theta. And from my reciprocal identities, if you don't remember our reciprocal, we know sine theta is equal to 1 over cosecant theta. Cos theta is equal to 1 over secant theta. So I can change this 1 over sine theta to just be a cosecant theta, and this 1 over cos theta to be a secant theta. And now we are left with what is on our left side. And we have proven this identity. You don't actually have to write all of these in. I don't care, but I'm going to write them in. So cosecant theta equals secant theta. Cosecant theta equals secant theta. And proof is over. So you're always going to have to remember those reciprocal identities from the last lesson. You can't just get rid of them now. I'll write them over here real quick. Okay, there they are. So let's do example 2 now. I have cotangent cubed theta equals a whole bunch of stuff. So I'm going to leave that cotangent cubed theta because I don't know what to do with that. But I'm going to look at this, and I see that there's a cotangent theta in both of them, so I'm going to take one out. So that leaves me with cosecant squared theta minus cotangent theta. Just kidding, minus 1, because I took the cotangent out. And I know that cosecant squared theta minus 1 also makes it a cotangent theta squared theta. So this is the same as cotangent theta times cotangent squared theta. And now I have a cotangent squared times a cotangent makes it a cotangent to the power of 3 theta. So that one was really easy. Sometimes when you're doing proofs, you kind of just got to try something, and then if it doesn't work, like whatevs, maybe you'll figure it out. I like to do all of mine on scrap paper. Oh, okay. All right, next examples. They weren't on the next page. So for this one, I'm going to leave the left hand aside, leave that one, and I'm going to do the right side. And what I'm going to do is I'm going to multiply by what's called the conjugate. It's something you did in Pre-Cal 20, but I'm going to multiply by 1 minus cos theta. So I have sine theta minus sine theta cosine theta over, and now this is going to be, because it's the opposite, it's going to turn into 1 subtract cosine squared theta, which is awesome, because now I can change that into a sine for this. So I have sine theta minus sine theta cos theta all over sine theta. I can take out a sine theta, and this becomes 1 minus cosine theta over sine squared theta. And then we're going to get rid of the sines, but we're only going to get rid of 1 on the bottom. So we're left with 1 minus cosine theta over sine theta. And that is where we wanted to end. It is the same as that. All right, next proof, we're going to do the same thing, but we're going to do the conjugate for each. So this one we're going to multiply by 1 plus cos theta, and this one we're going to do by 1 minus cos theta. So this is going to turn into 1 plus cos theta over 1 minus cos squared theta plus 1 minus cos theta over 1 minus cos squared theta. And now our bottoms are the same, and I'm going to change them into a sine because that's going to be easier. So we have 1 plus cos theta plus 1 minus cos theta, and this is all going to be over sine squared theta. So this and this are going to cancel, so I have 2 over sine squared theta, and I can change sine squared theta to be cosecant because it's on the bottom, so we have 2 cosecant squared theta, and that's what we were trying to get to begin with. So we are done. So there's our proof. Okay, last example is we're going to use algebra to solve 3 minus 3 cos theta minus 2 sine squared theta equals 0 over the domain of 0 to 3 pi over 2. So that's from here to here. Okay, so what can we do here? So first of all, I've got a sine here, and I really don't feel like I should be using a sine when the other ones are cosines. So I'm going to change that sine squared theta, or x, to be 2 times 1 minus cos squared x, because I can use this rule right here. So we have 3 minus 3 cos x minus 2 plus 2 cos squared x, and now I'm going to write this in descending order. So I have 2 cos squared x minus 3 cos x plus 3 minus 2, so plus 1 equals 0. Now I'm going to factor two numbers that add up to make negative 3 and multiply to get 2. Our numbers are going to be negative 2 and negative 1. Our a value is not 1, so I'm going to have to do all of the steps. So I want you to pause the video, and I want you to factor this. So you should have got 2 cos squared x minus 2 cos x plus, or minus x, cos x, plus 1. We have a 2 cos x common in the first one and a minus 1, so it factors out to be 2 cos x minus 1 and cos x minus 1. So we can have each of these things equal to 0. So we can have cos x equals 1/2, or we can have cos x equals 1. So we can answer both of those things. So cos x is going to be 1 at 0, and that's it, at 0. So this one, the answer is 0 pi. And cos x is going to be positive 1, or remember we're dealing from here to here. So it's going to be 1/2 at, right here, at pi over 3. And it's not going to hit another positive because the next positive would be quadrant 4. So x can be equal to pi over 3, or it can be equal to 0. And that's it. Those are our only options. I'm trying to circle this. All right, and that's the Pythagorean identities.